Hello, welcome everyone. This is Naghmana. So we are going to do Maths Methods Exam 1 2020. And this is from question number 6. For other questions, question number 1 to 5, please watch the other video, part 1 of this video. And we're going to do question number 6. So let's see what we can do. What is the question saying? So we have a function which is defined from 0 to 2 to r and f of x. The rule is given. The question is find the domain and the rule of f inverse and the inverse function. So it's a 2-mark question and they're asking us to give us the domain and the rule for f of inverse. Okay, so what I could write that function y is equal to 1 over root 2 and then root x. To find out the inverse, what we need to do, we need to replace x with y and y with x. And by doing that, we're going to get we're going to do this, y is equal to x. So this will give me x is equal to interchanging them around. So what we're going to get is 1 over root 2 root y. And then we have to solve that for y. That would be the inverse function. So take the root 2 on the other side of the equation, we get root y, and then taking the square would give us y is equal to 2x squared. So that is and this y is the same as saying f inverse of x. So that is the rule. That's what it says, the inverse function we got. Now we know we need to find out the domain. As we see that the domain of f of x is 0 to 2, and with this, when x is 0 to 2, it's a square root function. So range of f would be, range of f is 0 to 1. So that's the range of what? The function f. So as we know, the inverse of the function means the domain range of f becomes the domain of f inverse. So that means the domain of f inverse would be 0 to 1. To get the 2 marks of this question, so you have to show this working out and write the domain of that. Okay, so now the next one is the graph is given. If we see that, the graph of f is given here. On the axis above, sketch the graph of f inverse over this domain. Label the endpoints and points of the intersection and give their coordinates. Okay, so there are 2-mark question, but each step has some marks on it. So we need to answer that carefully. So we're going to inverse function. We know that it's a parabola, 2x squared. And the 2x squared, the function would start there and it would gonna go. But before I draw that there, what I need to do is I need to first find out what are the endpoints so that we don't make mistake on the graph. We should know where the graph is going to go. So we know that the domain is 0 to 1 of f inverse. So that means that when x is 1, y would also be 1. So when x is 1, y is 2 times 1 squared, which gives you 2. So when x is 1, y is 2. So that is the one of the endpoint, right? So, and you can label that 1, 2. And then we say 0, 0. When x is 0, y is 0. So that would be our one of the point. And then we also need to find the point of intersection. Point of intersection is where the both of them are intersecting. So you could go and say 2x squared is equal to 1 over root 2 root x, where both of them are going to intersect. So we can find that out by solving this. So let's see what we can do with this one. So then we can have, taking the square on both sides, we get 4x4 is equal to x over 2. So that will give me 8x4. minus x is equal to 0. So that give me x 8x cubed minus 1 equal to 0. So one of the point of intersection x is 0, and the other one would be x is equal to 1 over 2. When x is 1 over 2, then that means y is equal to 2x squared. So that gives you 1 over 2 squared. And that also gave me 1 over 2. So that means the point of intersection is a half and half and 0, 0. So 0, 0, we already know. The half and half, it was the main thing in there. We need to find out that. And now we know this, all the endpoints, and then I can go and graph it. Now, it's a parabola, which is going like this. Okay, so that would be the graph. Is a bit wiggly, but never mind. So we can ignore that bit. So we got that inverse function. So we label that endpoint in here. We label this endpoint in there. And then you also label the point of intersection, which is 1/2 and 1/2, and then 0, 0. Or you also know that this inverse function is the reflection of the graph along the line y is equal to x, which is, you could easily see that that line is this one, right? So that would be the line y is equal to x, where that's the graph is just a reflection of that. Okay, so we're done with this part of the question. Now let's see what is the next part says for us. So we have here is find the total area of the two region, one region bounded by the function f and f inverse, and the other region bounded by f inverse, the line x is equal to 1. And we also need to give our answer in this form. So we have to, if we go back into the previous page and see which region that we're looking for one of the region is bounded between the f and f inverse. So that would be this region we're talking about. And then we also talking about the region between the f and then the line between 0 to 1. So this region we are talking about. So what does that mean? That means we are going to find the area. So area is equal to, the first one is 0 to 1/2, right? And then we have f minus f inverse, right? F of x minus f of n inverse, because f is on the top, dx. And then we also need to do is 1/2 to 1, because the line between the f inverse and the line x is equal to 1. And that should be equal to f inverse of x minus f of x dx. So it's a 4-mark question. So definitely that's what we need to do from there. Okay, so let's see what we can get from here. Now we just need to 0 to 1 over 2. Our f of x was 1 over root 2 and root x minus f inverse, which is minus 2x squared, and dx plus 1/2 to 1, f inverse is 2x squared minus 1 over root 2 root x dx. Okay, so now let's do the other integration from there. So we're going to do is we will get, so root x to the power 3 over 2 divided by 3 over 2, which give you 2 over 3 root 2 minus 2x cubed over 3, and the limit is 0 to 1/2, plus then we have 2x cubed on 3 minus 2 root 2x to the power 3 on 2, x to the power 3 on 2 over root 2 3 root 2, and limit is 1/2 to 1. And then we just need to do upper limit minus lower limit, which would give us and then 0 plus 2 over 3 minus 2 over 3 root 2 minus 2 over 3, 1 over 2 to the power 3 plus 2, 1 over 2, 3 over 2 over 3 root 2. And then we just need to simplify that. So that would be equal to root 2 and 2 to the power 3 over 2 minus 2 over 3 times 8 plus 2 over 3 minus 2 over 3 root 2 minus 2 over 3 times 8. Okay, so that would give you plus 2 over 3 root 2 and 2 to the power 3 on 2. So you see these two are the same term, these two are the same term, these two are the same term. So this will give us 4 over 3 2 to the power 2 and minus 4 over 24 plus 2 over 3 plus 2 over 3 minus 2 over 3 root 2. So this will give me 1 over 3 minus 1 over 6 plus 2 over 3 give me minus 2 over 3 root 2. This gives me 1 minus 1 over 6, which gives you 5 over 6 minus 2 over 3 root 2. And then we can, because we have to come up with this kind of answer for that. So this one can be written as 5 over 6 minus root 2 over 3. And because that's cancel out, and we can make 6, 5 minus 2 root 2 over 6. If we see that, so that's A is 5, B is 2 in that one. So that should be our answer for that. Okay, so worth 4-mark question, lots of working that out. Okay, so now we have question number 7, where it's a parabola function, graph is given, where its p is 1, 0. Part of the graph y is equal to f of x is shown. Show that the p is not on the graph y is equal to f of x. So how can we show that p is not on the graph? So what we need to do is we just need to do f of 1 and see what we get. So 1 squared plus 3 plus 5, which is equal to 4 plus 5 is 9, which is not equal to 0. So that means we can say that p of 1, 0 is not on the graph of f of x. Okay, so 1-mark question. So nice and easy, quick. So consider a point Q to the point to be point on the graph. Find the slope of the connecting P and Q in the terms of A. Okay, so we say slope of P and Q. So P is, we said, is 1, 0, right? And Q is A f of A. So Q would be A comma what? A squared plus 3a plus 5. And the other point is, this is our Q point, P point is 1, 0. So the slope would be rise over run, which give us a squared plus 3a plus 5 over a minus 1. And can we simplify it further? Doesn't look like it. We can just leave it like that. Okay, find the slope of the tangent to the graph f at point Q in terms of A. So now we need to find out the tangent, slope of the tangent. What does that mean is you're going to differentiate the function. F dash of x would be equal to 2x plus 3. And then we need to sub in the point. So f dash of A is equal to 2a plus 3. So that should be enough for this question. Okay. Now the next part of the question say, let the graph be, let the tangent to the graph at x passes through the point P. Find the value of A. So what we're saying is the tangent, which is the y is equal to f dash of A. This is our gradient times x plus c, right? So f dash of A, we're saying this tangent passes through the point. So we know f dash of A, we just got it, which is equal to, on the previous page, we got it 2a plus 3. So that means this is 2a plus 3 times x plus c. So that is the tangent which is passes through the point A. Okay, so that means we can say passes through the point at the point x is equal to A. So then we can go and say, okay, so we go y minus, now we need to use this point A, and f of A is a squared plus 3a plus 5 passes through this point. So that means we can say a squared plus 3a plus 5 is equal to 2a plus 3 times a plus c. So we want to find out the y-intercept. So take everything on the other side of the equation. 3a plus 5 minus 2a squared minus 3a is equal to c. Some things cancel out and we get c to be 5 minus a squared. Okay, so that means the equation of tangent line would be y is equal to 2a plus 3x plus 5 minus a squared. Okay, that is, and then we need to pass it through the point P, find the value of A. What was the point P? Point P is 1, 0. That's the P point. Now we need to use that, means we're going to sub in there. X is 1, Y is 0 will give us 2a plus 3 plus 5 minus a squared. So this would give me there is a squared minus 2a minus 8 equal to 0. And that will give me, if I factorize it, a squared minus 4a plus 2a minus 8 equal to 0. So that means a minus 4a plus 2 equal to 0. And that give you a is equal to 4 and a is equal to negative 2. So these are the two values of the a we got. Okay, give the equation of one of the line passing through the point P. That is the tangent to the graph F. So give the equation of one of the line, because we got two values of A, right? One of the line mean you could say A is equal to, let's say 4, and we can see what we get. So A is equal to 4, we are going to get, this was the equation of the tangent line. Let me highlight that. This one. So we're saying when A is equal to 4, what we're going to get is y is equal to 11x minus 11. Or we can also say when A is negative 2, y is equal to what? Negative x plus 1. Okay, now we have the next question, which says find the value of k that gives the shortest distance between the graph of the function of y is equal to f of x minus k at the point P. So for this one, what we need to do is find the value of the k wherever it's possible to give the shortest distance. So the shortest distance here could, because the graph we have is y is equal to f of x, a parabola, right? So we want to find out the shortest possible distance between the graph of y is equal to f of x minus k. So that would be the turning point. Yeah. So the turning point would be f dash of x, we know is equal to is 2x plus 3, right? So we're saying that is equal to 0, and that means we'll give you x is equal to negative 3 on 2. So that is the negative is that is at the turning point. So now what we're saying is that translating f of x so that the turning point is above the point 1 comma 0. So that means we get k is equal to negative 3 on 2 plus 1, which gives you 5 on 2. Okay, so the turning point is giving us the minimum of the graph, right? And the f of x is now we are saying is 2.5 in the positive x direction of the so that the turning point is directly above the 0.00, which k is equal to 5 on 2. Okay, so now we have question number 8. Part of the graph is given with this log graph, which from 0 to infinity. The graph has a minimum at this point. Find the coordinate of the point Q. So the graph has a minimum. What does that mean? So that means we need to find the stationary point. And we say f dash of x is equal to x log ex. So we're going to differentiate it. We get x times 1 over x plus log ex, which give me 1 plus log ex is equal to 0. And that will give me log ex is equal to 1. That means x is equal to e to the power negative 1, right? So that is equal to 1 over e. So if x is 1 over e, what would be the y? Y would be is equal to 1 over e log e 1 over e. And that will give me negative 1 over e log e. And that is equal to 1 is negative 1 over e. So that means the Q point should be 1 over e and negative 1 over e. So that's the point Q. Okay, so now the B part says we want the derivative using this, the derivative is equal to that. Show that x log e has an antiderivative of this. Okay, so what we need to show that the x log e has this antiderivative. Okay, so that means we go x log e x dx. That's what we want to find. Can we rewrite it by using this given expression? Can I say that x log e x is equal to what? Take this on the other side. It would be d over dx, x squared log e x minus x, and then 1 over 2 at the front is equal to this. So we can rewrite that, rearrange that equation and write it like that. So that means this is equal to, this whole thing is equal to 1 over 2 d over dx, x squared log e x minus x dx. And then we can rewrite it. Take the 1/2 of the outside, d over dx, x squared log e x minus x dx, right? So that's the whole thing. You know, derivative and antiderivative are inverse of each other. Cancel out, we get x squared log e x minus x squared over 2, which has become now x squared over 4 because 1/2 is at the start. That is equal to, antiderivative of that is equal to this. Okay, so so that's what we wanted to show. Now we need to, and then you could say plus arbitrary constant. And this arbitrary constant we don't have here because it's arbitrary constant. You can say that therefore C is equal to, we can assume that C is equal to 0. So that is like, let C is equal to 0, we get 1 over 2 x squared log e x minus x squared over 4. Could be possible, right? And now we have C, find the area of the region that is bounded by F, and the line axis equal to A, and the horizontal axis, where B is the x-intercepts of F. Okay, so we need to find out the area bounded by f, the line x is equal to a, and the horizontal axis. If you go back into the graph, we say line this, we go from x is equal to, so that's the function with there. So we want to find out the area, which is, that means we need to integrate that function. So integrating from where? So because it's the region we are looking for is below the x-axis. So that means that you say area is equal to x log e x dx. Okay, so we're finding the region bounded by the graph and the line x is equal to a. Let's see, where is the line x is equal to a? So that would be there. So if I graph it, like I draw that line, it would be look like this, right? So that means we are talking about this region here. So it would be from 0 to this a value, which we got already is 1 over e2. No, I don't think so. We're looking for that. We just 1 second. I think we line x is equal to a, and then say the horizontal x-axis, xa to b, where b is the x-intercept. Okay, yeah, that's better. I didn't read that line carefully. So let's see. We are saying the b means, if I go back in here, we are talking about this bit there. Okay. So that's the x-intercept. When b is the x-intercept, means where y is 0, that means x is equal to b is equal to 1. Okay, so that means this limit would be negative because it's below the axis. So limit would be 1 over e to 1 because b is 1 there. Okay, and we already know the integral of that. This answer, we got it up in part b. We could just going to use that 1 over 2x squared log ex minus x squared over 4, and the limit is 1 over e to 1. Okay, so then you go upper limit minus lower limit. If you sub in 1, you get 1/2 log e1, which is 0, right? Minus 1 over 4 minus 1/2 1 over e squared log e 1 over e minus 1 over 4 e squared. And that will give me, this is 0, so we get minus 1 over 4 e squared log e. So that gives me 1 as well. Minus 1 over e squared and minus 1 over 4 e squared. And there is 1 minus outside. That will give me 1 over 4 plus minus 1 over 2e squared minus 1 over 4e squared. Okay, so that would be 1 over 4 minus 4e squared, and that will give me -3. And that means I could write it like 1 minus 3 over e squared. So that should be it, or I could leave it like that. I don't know, it's just a way of writing answer. You could write it like this. So that gives you e squared minus 3. So that could be one other way of writing your answer. Okay. Now we have the D part of the question where G is a function which is defined from a to infinity, and G of x is f of x plus k. B is being translated. And find the value of k for which y is equal to f of x is a tangent to the graph G. So when we have G of x is look like, we said f of x is x log e x plus k. Okay, so we're talking about the tangent. So what would be g dash of x? G dash of x is going to give us the gradient, right? So we're looking for g dash of x is equal to, k is the number, right? So that gives you 1 plus log ex. We already did that in the previous question. Now we're saying this is our g dash of x, and with y is equal to 2x is the tangent. What does that mean? That means I'm saying 1 plus this is equal to 2 because that's the gradient, and here the gradient is 2, so that's equal. So that gave me log x is equal to 1, and that also mean x is equal to e. So when x is equal to e, that's the same. That means y is equal to 2x give me y is equal to 2e. So that also give me that if I sub in g of e into that, we should get e plus k, and that means this value and that value. And we can say that e plus k should be equal to 2e. That means k is equal to e. We're looking for that k value. Okay. Next part of the question is find all values of k for which the graph g and g inverse do not intersect. So when we say is intersect g and g inverse, okay, so what we have to do in this one is we say, so there are different ways to approach this question. One of the way is when we say, we just did that, say g dash of x is what? 1 plus log ex, right? And we're saying if that is equal to 1, and then that will give me log e x is equal to 0. So this will give me x is equal to 1. Okay, so when x is equal to 1, that means y is equal to 1 as well. When x is 1, y is 1. So g of 1 is equal to g of 1 is equal to k. That means it's equal to 1. So that's when they intersect, right? So, but when there's do not intersect when k is greater than 1. So that means do not intersect. Okay, so do not intersect means that k has to be greater than 1 in there. Okay, thank you. I think this is the end of the question. Please feel free to share and subscribe